Hello everyone, this is in continuation of our lecture series of gravimetry. A quick recap of the conditions which are required for the precipitation of the required precipitate. The solutions which are to be used in gravimetric analysis should be dilute, they should be hot, the constant stirring should take place. The precipitating agent which should be added very slowly. Always a small excess of the reagent should be added. The pH should be adjusted according to the requirement of the precipitate. The electrolyte should be added. After that, the digestion of the precipitate needs to be carried out, and the electrolyte is to be added in the wash solution to reduce peptization. As we have already discussed, peptization is a source of error in gravimetry, wherein the precipitate passes into the colloidal form and hence passes through the filtering medium. The nature of the precipitate decides the filtering medium, whether the filtering medium is a simple Wattman 40 filter paper or whether the precipitating medium and filtering medium is crucible, sintered glass or nickel crucible. And once the precipitate has taken place, the washing of the precipitate is to be done to remove any soluble impurities. This is what we have discussed in our last slides, and the washing of the precipitate needs to be carried out with certain wash solutions which have certain requirements. That is, electrolytes need to be added to the wash solutions. The washing of the precipitate needs to be carried out in case where the solubility of the precipitate should be minimum, and this can be done by keeping one ion in common with the precipitate. All these points we have already discussed when we were discussing washing of the precipitate. The wash solution should be such that it should not cause hydrolysis of the salt of a weak acid or a weak base. For example, if ammonia solution is used to wash the precipitate of magnesium ammonium phosphate, which gives basic solution on hydrolysis. So as we can see over here that magnesium ammonium phosphate has one ion ammonium in it, and therefore the wash solution which is to be used should have an ion which is common with the precipitate, and that is to minimize peptization. Reducing substances also need to be added to wash solutions in case where the precipitate formed is prone to oxidation. In that case, certain reducing substances like sulfurous acid should be added to the wash solutions, and the wash solution should be used in as little quantity as possible, otherwise peptization may occur. When we talk about peptization, which is a source of error, if wash solutions are used in larger quantities, then it may result in the solubility of the precipitate, or it may result in the passing of the precipitate into the peptization form or colloidal form, and that process, which is called peptization, should be avoided. Also, the washing should be done by adding the wash solution in small lots rather than one big lot, and this is again to avoid peptization. Warm wash solutions can be used to increase the speed of filtration. If cold solutions are used for washing, then the speed of filtration might decrease in the case where the cold solutions might, since they are more viscous, they might slow down the speed of filtration. Heating or ignition is done as required depending upon the nature of the precipitate. So if the precipitate is prone to decomposition at a high temperature treatment, that is on ignition, then the precipitate should be simply heated to remove the water of crystallization. Whereas if water of constitution is to be removed and the precipitate will not decompose on ignition, then that process should be carried out. This is a figure which is depicting how after precipitation the filtration of the precipitate is carried out, and this filtration is done through a Wattman 40 filter paper. The pore size of Wattman 40 filter paper is very small, and it does not allow precipitates to pass through it. So the Wattman 40 filter paper is taken and it is made into the shape of a cone as it's seen in the figure. That cone is fitted into a funnel. Simply precipitation or simply filtration through the funnel might not be at once possible, because since the pore size of the Wattman 40 filter paper is so small, it also sometimes retains water in it. So to speed up the filtration, sometimes this process is carried out on a suction. With the help of pressure, the water is sucked through the funnel and on the filter paper remain only the precipitates. So, to speed up the filtration, the solution, the wash solution should be hot and the filtration can be carried out using pressure. After we have discussed the washing of the precipitate, which is important to remove any kind of impurity which is attached to the precipitate, we now need to consider another method of precipitation, which is termed as precipitation from homogeneous solution. In this kind of precipitation, the precipitating agent is not added from outside but is created within the solution by a homogeneous chemical reaction. The advantage of this particular method is the speed of precipitation can be controlled in this manner, because the precipitation can only be as fast as the generation of the precipitating agent. As we have already discussed, the precipitation should be carried out slowly and the precipitating agent should be added in small lots and slow addition to take place, and that is to increase the size of the precipitate, to increase the quality of the precipitate. So, the speed of precipitation needs to be controlled by either controlling the addition of the external precipitating agent, or the precipitation can be carried out in homogeneous solution where the precipitating agent is created from within the solution. So, rate at which the precipitating agent is created or it is formed will be controlling the rate at which the precipitation is occurring. So, the effect of concentration on particle size is controlled and dense filterable precipitates are obtained. The density of the precipitates is again increased in this case, wherein a small nuclei of a precipitate is formed and it serves as a ground or as a nucleus for precipitation of other particles on it, and hence the density as well as the size of the precipitate increases. Therefore, slow addition of the precipitate needs to be done, or the precipitation can be carried out from homogeneous solution. In this method, that is precipitation from homogeneous solution, co-precipitation, which is another source of error in gravimetry, can be avoided. However, this particular method may not be possible for all estimations, because it may not be possible to create a precipitating agent from within the solution in all the cases, because in many of the cases external addition of the precipitating agent is required. We can discuss some examples of precipitation by homogeneous method. The first example, as we can see, is the hydrolysis of urea. The reaction which shows the hydrolysis of urea producing ammonia and carbon dioxide. The quality of the precipitate can be enhanced by the addition of another ion. For example, for the precipitation of aluminium ions, using homogeneous solution method of urea hydrolysis, which we have just discussed, the reaction of urea hydrolysis in which urea is reacting with water to form ammonia and carbon dioxide. This particular reaction can be used to precipitate a particular metal ion in solution, and in this case we are discussing the example of aluminium. By using homogeneous solution method of urea hydrolysis, the addition of succinate, formate or benzoate ions give a very good precipitate. That is, for the precipitation of aluminium ions using urea, in which carbon dioxide and ammonia is being produced, and this is basically to provide a basic medium or alkaline medium, and the compound which can be precipitated is with the help of succinate, formate or benzoate ions. And this is because these ions give basic salts which form a dense precipitate. That is, these ions form basic salts with aluminium ions, as in terms of aluminium succinate or aluminium formate or aluminium benzoate. Urea hydrolysis in the presence of formate ions, ferric ions, gives basic ferric formate which is easily filterable and can be ignited to give ferric oxide in the final form. So, apart from succinate or urea hydrolysis being used for the precipitation of aluminium ions, it can also be used for the precipitation of ferric ions, and ferric ions form good complex with formate ions which gives basic ferric formate. Now, basic media is created by urea hydrolysis. So, the media will keep on changing at the rate at which urea hydrolysis is taking place, and after ferric formate forms, then this ferric formate is very easily filterable, but since it does not have a definite composition, therefore it needs to be ignited, in which ferric formate ignites to give its oxide, that is ferric oxide in the final form, which can be dried and then weighed to give the exact amount of ferric ions in a particular solution. Aluminium can be precipitated as aluminium oxygenate, and this can also take place in homogeneous solution. Urea hydrolysis is important for maintaining pH for those determinations where pH is important. That is, in cases where alkaline medium is needed or pH needs to be on the basic side, in that case urea hydrolysis is very important, as in case of homogeneous solution precipitation method. Urea hydrolysis can also be used for the determinations of barium ions as barium chromate and nickel ions as the nickel dimethyl glyoxime complex. So, we have seen so many ions which can be precipitated out in terms of the precipitation from homogeneous solution using urea hydrolysis. Some other ions, for example phosphates, they are generated from triethyl and trimethyl phosphate in acidic solutions, and they can be used again as an example of precipitation from homogeneous solution method. Zirconium, for example, can be determined as its phosphate where dilute sulfuric acid is used with triethyl phosphate. After ignition, zirconium pyrophosphate is obtained, which can be weighed to give the exact amount of the zirconium ions present in the solution, since zirconium precipitates out as zirconium pyrophosphate after ignition, and this process is carried out, the ignition process is carried out in this case because zirconium pyrophosphate contains certain zirconium water molecules which need to be removed. Bismuth ions can also be determined as bismuth phosphate by the controlled hydrolysis of metaphosphoric acid to give orthophosphate ions. So, bismuth ions can also be precipitated from homogeneous solution method, and once bismuth phosphate is formed, then in this case it is weighed as such because bismuth phosphate has a definite composition. It is first filtered, then ignited and can be weighed. Similarly, oxalates can also be determined like this. Bioxalate in the presence of ammonia gives oxalate ions very slowly, and the reaction which shows ammonium ions, H plus ions and oxalate ions are produced. Now this reaction or this process is suitable for the estimation of calcium ions as calcium oxalate. So if one needs to estimate the amount of calcium ions in a particular solution, then apart from various other techniques which are involving volumetry and certain other ion exchange methods, gravimetry can also be used for the estimation of calcium ions. Calcium ions form insoluble precipitates with oxalate ions. Either oxalic acid can be added from outside to precipitate calcium as calcium oxalate, which might give an error because calcium oxalate or basically the oxalate ions tend to get decomposed on high temperature treatment. So to avoid that, this precipitation can be carried out in homogeneous solution, and in this case oxalate ions which are produced are in a controlled environment, since the amount of oxalate ions or the concentration of oxalate ions which are produced is equivalent to whatever amount is required for the precipitation of calcium as calcium oxalate. So the precipitation is slow and it is therefore good in that sense that the precipitate size is large, it is dense, that is the quality of the precipitate which is formed is very good and can be weighed easily. Another group of ions like sulfates can also be used as in case of precipitation from homogeneous solution. Organic sulfates can be used in acid solution, which are suitable for the estimation of barium ions. And as we can see in the reaction over here, dimethyl sulfate on hydrolysis gives methanol plus H ions and sulfate ions. The sulfate ions which are being produced in this reaction are in a very controlled concentration, and the amount of sulfate ions which are produced is comparatively less and suitable for the estimation of barium. After precipitation has been carried out by various methods which have been discussed earlier and also by the homogeneous method of precipitation, these precipitates need to be dried so that they can be weighed to get the exact amount of the metal ion in it. So the ignition of the precipitate can be carried out, or simply low temperature heating of the precipitate is to be carried out. So low temperature of heating of the precipitate is sufficient when simply adhered or adsorbed. Adsorption is a surface phenomena, that is the impurities are or the water molecules are simply attached to the surface of the precipitate. So that can be removed by simply the low temperature heating. So when simply adhered or adsorbed moisture has to be removed from the surface of the precipitate, then that precipitate needs to be heated at a temperature of 100 to 110 or 20 degrees centigrade. This experimental setup, which can be seen in the adjoining figure. In this case, in the figure we can see the heating which is to be carried out either on a Bunsen burner or in an oven, or the ignition which is to be carried out on a burner wherein the precipitates are taken in a crucible and that crucible is kept on the flame and is heated to more than 200 degrees centigrade till the precipitate gets charred out, or rather the filter paper which is wrapping the precipitate gets charred out and the precipitate is obtained as such in the crucible. The precipitate which is now obtained on heating this at a very high temperature, or as we say igniting it, is free from all kinds of moisture. Ignition of the precipitate is therefore done to remove all the water of crystallization, water of constitution, and sometimes also to change the chemical form of the precipitate. In cases where one particular chemical form of the precipitate is easily susceptible to decomposition and cannot be weighed as such, then the ignition of the precipitate needs to be carried out so that the precipitate is changed into a form in which it can be weighed easily. So, ignition can be carried out to remove the water of crystallization, water of constitution, and also to change the chemical form of the precipitate, that is the form in which it can be weighed easily. So, for ignition, the precipitate is filtered through an ashless gravimetric filter paper. Now, what do we understand by ashless gravimetric filter paper? This is again the Wattman 40 filter paper, not the filter paper we generally use in the lab for day-to-day filtrations in small experiments, but it's a special kind of a paper which does not leave any ash upon burning. So, therefore, it is called ashless gravimetric filter paper, and after that the precipitate is ignited. That is, once the precipitate is filtered through this filter paper is folded carefully so that there is no opening through which the precipitate might fall out, and this filter paper is put in a crucible and the crucible is burnt on a flame. After burning or after incineration, as we call it, the gravimetric filter paper starts charring, it starts burning, and if we keep this process on, then ultimately whole of this gravimetric filter paper burns out and it releases carbon dioxide and water, and what we are left in the crucible with is the required precipitate. This needs to be carried out, the incineration, as we say, needs to be carried out in a silica crucible or a platinum crucible. Crucible is a small kind of bowl in which the ignition needs to be carried out. Incineration is carried out without inflammation. That is, care should be taken that while the precipitates or the filter paper containing the precipitate is being burnt, it should not catch fire. If in case that happens, it might result in the loss of the precipitate. So, if the precipitate catches fire, then there may be the mechanical loss of the precipitate. Heating the precipitate to a high temperature further is required to remove all the ash. The ash which is there from the filter paper which has been burnt, although it does not leave any ash, but if in case some of the ash is there, then further heating can remove that also. For example, if you have calcium hydroxide is filtered through a Wattman 42 ashless filter paper and it is burnt. Upon burning, the water of constitution from calcium hydroxide is removed and calcium oxide is obtained, which can be further weighed out. The temperature of ignition of the precipitate can be decided according to the kind of water to be removed. That is, if simply adhering moisture is to be removed, then the precipitate needs to be heated at about a temperature of 100 degrees centigrade, which is achievable in an oven. If adsorbed moisture is to be removed or water of crystallization is to be removed, then a slightly high temperature heating needs to be done, and if water of constitution is to be removed, then ignition needs to be done, since simply heating will not remove the water of constitution. By the gravimetric analysis of a precipitate, one can determine the amount of the precipitate which has been formed in a particular solution, and from that, by the thermogravimetric analysis, one can also determine the amount of a metal ion in a particular solution by the gravimetric process, or as we say thermogravimetric process, which is thermo means related to temperature. So, temperature which can be increased or decreased depending upon the quality of the precipitate and the quality of the water or the kind of water which needs to be removed. Thank you.